All right, we are down here today in the monitor dungeon, if you will, because I need to go through here and start working on all these chassis. And I'm starting down here to just give you a showcase of what we have. So, I mean, as you can see, if you've seen some of the videos, this is just the giant overflow of everything that I've got. All this stuff here are all chassis that are completely repaired, working, ready to drop in at a moment's notice on anything that needs dropped in. All this row here too, there's probably, I don't know, 30 of these chassis just sitting here ready to drop into a monitor at any moment's notice. And then I got a whole row here of 27-inch monitors that are complete. All these monitors are complete and ready to drop in a machine at any moment's notice. So these are all 27s all around here on the bottom because they're the heaviest. The 25s are all here along the middle, and the 19s are all here along the top, except for two 13-inch VGA monitors out of some poker machines. But and then there's 3 entire rows here of 19s stacked on top of each other. So these are all spare tubes I have sitting out that I knew I was going to have to use for testing these, like the K7000, which I can use the 7000 for the 7000s, the 2000s, the 5000s, the 7400, and I think those 3, and Neotecs and standard rest Neotecs and stuff. Henrix Polo, G07, K7000 skinny neck, 4900, 25-inch, 27-inch, 7500s, things like that. So I've got the normal regular test tubes sitting out here on hand, but the stuff that's complete, that's ready to drop into a machine, are all around here. But the purpose of this is I've got all these giant boxes here full of chassis that need to be gone through. If I was to do one video a week, I probably have enough content just here for almost a little bit more than a year. If I had to guess, there's probably about 60 chassis here total, maybe more. There's a giant box here all the way to the top, full of stuff. All these are loose chassis in these boxes. This whole giant box there, this box here I think has a couple in there. There's a couple in there. This box there, this giant tub. There's a box down there, a box right there. This whole box here is full, all the way to the top and overflowing, of the U5000, U2000, K7400, K7500. I think there's like 10 or 11 in there. So that'll be fun just going through all those individually. There's a 13-inch K7200 here, which I don't have a 13-inch tube, but we have a 13-inch K7200, which we'll have to figure out what to do with that at some point. There's 6 boxes here, 1, 2, 3, 4, 5, 6 of K7000s. Another box here, 2 K7000s. I mean, it's just, it's overflowing. It's time to start going through these one by one and seeing what we can figure out. I got a box here of K4600 stuff too, so it's going to be fun here next year or so. Maybe I can stretch these out for the next couple of years. So there's no end to the content, guys. It's just going to come down to if I have time to do all this stuff. So, you know, I have a regular life. I have to keep stuff repaired and working at the arcade on top of a regular 9-to-5 job, and you know, I got other stuff going on in here. I got all my pinball machines keep me busy trying to keep all these running. And of course the machines over there, they're pretty reliable for the most part. But you know, I'm having to fidget with some switches on Elvira and getting stuff fixed on Jaws and, you know, things like that. I got Star Trek Next Generation in a while back, had to go through that and get that all fixed up. And Back to the Future, got some stuff fixed up on that. So this keeps me busy as well, just like the machines at the arcade. So when and if I have time, that's when I can make these videos. So, but there isn't going to be any end to content for a long time. It's just going to come down to whether or not I have time to do these on a regular basis. So, but the chassis I've chosen here for this video is a 27-inch Neotec NT-27E. E for EGA, meaning medium res. So it's complete, but it is fairly filthy. If we look here, you can see NT-27E right there. So this is a 27-inch medium res. It does have the remote board, fortunately. Nobody reproduces these. So if you have one of these and it's missing, good luck. It has the pincushion board on the side here. So if you see one of these with a pincushion board on the side, it's pretty much guaranteed to be medium res. So, and or VGA, because the NT-2515C, the NT-2500 are both 25-inch standard res. The NT-2501 is medium res. So just like the 25 inch, the 27 inches are 2700 is standard res 27. 2701 is medium res 27. 2702 is VGA only 27. And the 27E is medium res 27. So I'm not sure why they have a 2701 and a 27E. They're different family versions of the Neotec. It gets pretty difficult to go through these and figure out what's what if you don't have the backing board here that specifically says what the model is. So anyway, it gets pretty interesting. So you have a 27-inch medium res Neotec here, and it's pretty filthy. So I'm going to have to go through and do a cleaning on this before I start working on it because it's pretty dirty. I'll put a link down in the description of the video, the procedure I do for cleaning these. So if you want to clean one of these yourself, you know what to do. So I'm going to go through and do a full cleaning on this. So when you see it back on the bench upstairs, you'll see it after, or when we come back, when I cut away and come back. Next thing you see on the video, I guess is what I should say, this will be clean on the bench, ready for testing and working. So, or testing and working on. So let's get this upstairs cleaned and get it on the bench, and we'll see if it works, what condition it's in. I have no idea on any of these. None of these are labeled. None of them have any tags that say was working, HOT shorted, blah, blah, blah. I have no information on any of them, so we're going to learn together what is wrong and fix them one at a time, hopefully. So we're going to get this upstairs, get it working, or start working on it, I should say, and see what we can figure out and how it goes. Oh, no, I'm sorry, I forgot. This is a medium res. Now, I do have two compatible Neotec setups down here, but as you can see, they're not viable to use because of how difficult they'd be to remove. So, that being said, I'm going to use this 25-inch K7500 tube and yoke. Now, these Neotecs are just like these chassis here, where the 25 and 27-inch ones are interchangeable. You can use 25 on 27-inch, 27-inch on 25-inch, vice versa, no problem. These are just like that. And I can hear you say already, well, I thought you can only use a K7500 on a K7500 tube and yoke and chassis. Well, yes, for long-term purposes, yes, you're correct. However, for some quick 30-second, 1 minute, 2 minute, 3 minute testing just to see and make sure the thing fires up and works and looks okay, you can use the 7500 to test medium res chassis. You can do it, trust me, there's nothing wrong with it. Now, if you're going to use it for 2, 3, 4, 5, 8 hours to do a burn-in, no, don't do that. But for some quick testing, just to turn it on, make sure it works, make sure it operates, make sure nothing is collapsed or what have you, you can do that. Now, the reason I'm going to use 25, the reason I'm going to use 25 is because I have a 27-inch 7500 here, but it has a chassis on it. It's adjusted, looks good. I don't want to mess with that. I can use a 25-inch for testing this 27-inch. It's going to work just fine. So we're going to use that tube there, and that's why these tubes are out here just for the testing. So let's get that done. Come back and I'll cut away. I'll come back. We'll have it on the bench, clean, ready for testing, see what we can figure out. All right, and here we have it, freshly cleaned, all spick and span, good to go. There's a couple spots where there's like some black goo or dark goo I couldn't just brush off with the brush, down in here as well, but overall it's looking spick and span, pretty much brand new from how it was, all that jazz. Now, I did discover here, after washing it and going over it real quick, is that we have the wrong remote board. Somebody has put a 25-inch, I didn't notice this until just now, but this is a 25-inch, like a 2500 or 2515C remote board, because the controls for this, for the digital pin cushion and the horizontal size, are missing because the connector is gone. So if we see here, I got a connection for all three of these connections, but this one right here, there's no header pins, and the digital pin cushion pot and the horizontal size pot are not there. There's no evidence that they were ever there. So this is the wrong remote board. I don't know if someone was trying to run this with this remote board installed. I hope not, because that would have taken out the HOT for not having a horizontal size adjustment. And if we look at the HOT, it's definitely been replaced. And this is the one that doesn't even, this is the kind of HOT that doesn't need an insulator, but someone put one on there anyway. And it looks like some cheap, the same cheap Chinese ones that are in the universal chassis. It may not even be the right package. So if I was a betting man, I would say that it's probably bad, and looking over the bottom of this, it looks like there hasn't been really any rework anywhere on this thing except for that. So it's obviously been replaced, and I want to test it here. Whenever you test these HOTs, you want to put your meter in diode mode, negative lead on the middle pin, and to each outer pin should be about 0.47 voltage drop, and we get, oh, dead short, HOT's gone. As I expected, and I'm assuming that probably happened because they never hooked up the horizontal size pot is out of circuit. That would definitely do it. Now I also want to mention here that on these 27-inch Neotecs there is a board on the side here. This is your pincushion board. Because you're going from 25 to 27-inch, it's a much bigger raster, so they put this pincushion board on here. There's an H-phase pot on the side here, which is not tied to your horizontal sink. It's tied to how much pincushion you have. So you use that in conjunction with the pot on the remote board for DPC, which is digital pincushion, this one here. And with that being missing, if someone tried to power this up with this remote board installed, they probably had a bad day. So I'm betting that if we were to just cap it, reflow it, and fix up this remote board, I'll bet, well, and change HOT, I'll bet it might work just fine, but you never know. That's wishful thinking, you know. I will say that this remote, or this pincushion board, if you ever have one of these that's working, but you cannot adjust H size, you go to adjust your horizontal size pot and it does nothing. There is a 5.6 microfarad bipolar cap right here that goes bad all the time. It runs hot, and it runs hot by itself. It also runs hot because it's next to this heatsink. So this will dry out, and when this dries out, essentially it goes out of circuit, and you have no H size adjustment control. So this will need to be replaced as well on our cap kit. I don't recall if it comes with the cap kit. There's so many different versions of these Neotecs. This is a what is this? Jai Chen? Something Chen. I can't remember what it's called. Jai Chen? I should have looked it up first, but that's why this is the amateur channel. So, your shutdown pot's right here. Your horizontal frequency, or your H sync, is this pot right there. Your horizontal position is right here. There's actually two H positions. There's an H hold, two H holds. There's an H hold right here. There's an H hold right there, supplementary. There is an H position right here and a supplementary H position right there. So you got to use all those in conjunction with themselves and things like that. But okay, so enough overview. It's clean. It hasn't been messed with, except someone changed the HOT, and probably because they didn't resolve this problem, it took it out. I'm assuming the power supply will be good. I'm also assuming the caps are going to be bad, so I'm not even going to bother. Trying to power this up. I'm just going to do a cap kit, a reflow, replace the HOT, try and fix this, test some other components, test our power supply. If that's good, then we'll just do the work I just mentioned, and then we'll try it. I do want to say that, let's say your power supply is faulty on these. There's a resistor, R106, this guy right in here. If you go to do your power supply test, as I'm going to show you here shortly, and you get the tick, 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 you lift this leg of R117 out of the chassis. This resistor right here, R117, you lift this leg out of the chassis, hook your light bulb to that, power it up, and if you get tick, 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 then it's likely either the IC101 is faulty or R106 is open. That's one of the two. So bear that in mind. If this doesn't work, we'll have to see if R106 is... It should read, actually, we can just test it now. It should read 820K, if memory serves, from the last time I did this. R1 was 820K. We get, well, it's in circuit. It's not open. If this resistor was open, we'd be reading in the megohm. The fact that it's not reading in the megohm and it's climbing, it'll eventually get to 820K, I'll bet. But it's not open. All we're checking to make sure is that it's not open. If this was open, we'd get a megohm reading. Well, hang on. Now we're getting a megohm reading. What the heck? Oh, it's going down. Huh. Why did it jump from 50K to 3 megohm? Huh. It's going down. Well, I'll tell you what. Let's just pull the leg of R117 out, hook a light bulb up, see if the light bulb lights up. If it does, then you got to test resistors out of circuit. The fact that it reads in the megohm may mean it's bad, but it's going to be easier to just go ahead and do our test and see. If the light bulb doesn't light up and it goes tick, 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 then it is bad. But anyway, so to isolate the horizontal output section from the power supply, we lift this leg of R117, and on this model of Neotec, the 27E, the Jai-Shen, something like that, I can't remember. It should be 113.5. The B plus should be 113.5. Now the light bulb that I have is a 60 watt incandescent, and it's not a perfect analog for a full load like the actual CRT would be, but it should be close enough. So we're hoping to see somewhere around 113.5. So now with that out, we can hook our light bulb up to this output leg of R117. Other lead on ground. Same thing for our meter here. Grab a couple of leads and we'll hook up our negative to the frame, positive to the resistor, positive to here. So if this works, okay, 0 volts, yeah, this should, if this works, we should get around close to 113.5-ish on here, and the light bulb should light up if our power supply is functional. I'm 50-50 because of our readings on R106. It's odd how it jumped from 50K to 4 megohm or whatever it was. But okay, so our output is isolated by taking R117 out. So let's see what happens here. Power is hooked up. 1, 2, 3. Yes, and 110.3. So yeah, we should be 113.5, but like I say, the 60 watt bulb is not a perfect analog for the full load that the CRT would have. So does our B plus adjust? Oh yeah, wow, okay. You can see the light bulb getting brighter there. So we'll leave it back at 110. We can adjust it later. So our power supply, good. HOT is shorted. I'll put a FJL 6920 in there. And with the light bulb hooked up, our filter cap has been discharged. This acts as a discharging system, so it's now safe to handle with the light bulb connected like that. So our filter cap has been successfully discharged by having the light bulb hooked up, so I'm not going to worry about that. Okay, well that's one step in the right direction, but if we did that test and it went tick, 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 it's likely R106 or the IC101, just so you know. Okay. Now, what do we do here? Let's, oh, and I noticed that the focus wire has broken off of the holder here, which we'll fix that, no big deal. That won't keep it from operating. So let's go ahead and put R117 back in before I forget, which will very likely would have happened if I hadn't have thought of it just right there after looking at it. And you guys want to hear what it sounds like with the shorted HOT? So now if I turn this on in this condition, it's going to energize the flyback and the horizontal section. However, since we know for a fact the HOT is shorted, it's just going to tick. That's all it's going to do. If the HOT is shorted in the circuit, it's going to prevent the horizontal section from firing up through the shutdown circuit. And all you hear is tick, 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 tick. So if you want to know what it sounds like for a shorted HOT, now a shorted or a faulty power supply is going to go tick, 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 tick. The power supply is a fast tick, 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 tick. A shorted HOT and a horizontal tick is a tick, 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 slower. So if you hear a ticking, a slow tick is a horizontal problem, and a fast tick is a power supply problem. So just as a show and tell here, I'll turn my fan off. I'll let you hear what it sounds like when you have a shorted HOT on these Neotecs. Here we go, listen. It's more of a chirp. Chirp, chirp, chirp. Now, if you had a situation where the power supply was the problem, it'd be going chirp, 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 chirp. So the sound of the chirping and the frequency, I should say the frequency, is a indication, or an indication, of what part of the circuit has faulted. Now, I do need to discharge that filter cap since we tried to turn it on. I don't think it'll have much of a charge on it, but we gotta discharge that. We can discharge that by simply hooking our light bulb back up here to 117 and ground, and let's see what happens. Yeah, it's discharged. So it's not like a G07 or something that'll zap the ever-loving crap out of you if you touch it. But so I think what we need to do is we'll replace the HOT, and then we'll try and figure out what we're going to do about this remote board situation. First, I need to... I'm still mystified why R106 was reading so oddly or strangely. Might be worth taking it out and just making sure it's 820K, but if it wasn't, then the power supply would not work, and our light bulb would not have lit up. So it's working. You just can't... That's why it's important to remove... If you get you can read some resistors in the circuit, but if you read a resistor in circuit, and it's supposed to be, for instance, 820K, and it reads, 3 mega ohm, you'd assume it's bad. So you have to remove it from the circuit and then test it again. You can't automatically say... So if I just went off, it reads 3 mega ohm. If I go, oh, it's open, let's replace it. Well, it may not be open. It may read 3 mega ohm in circuit because there's other stuff tied to it. But obviously it is working, and it is good because our power supply worked. If that was faulty, our light bulb would not have lit up. Although my curiosity is getting the better of me, and I want to just verify that it reads 820K. Let's where is that puppy at? That is right here. Okay, that's out. And it's lifted, and what do we get? It's hot, so it may not be exactly 820K, but out of circuit. Look at that, 840K. So, yeah, there's a good explanation, an example of just because a resistor reads funky in circuit doesn't mean it's bad. You got to pull it out of the circuit and test it out of circuit. Okay, and logic dictates that we know it was going to be good because the power supply was functional. All right, let's go ahead and replace this HOT real quick here. I also want to mention that there is a polycap that can go bad on these. Some of these, depending on the family version, full family version, non-full family, Genshin, whatever it is, they have different components in different locations. And some of these, I think the 2701, as opposed to the 27E, has a different polycap with a different rating in a different spot. But there is a polycap that's part of this HOT connected directly to it that can cause the HOT to fail if it's bad, and that is C415. This guy right there. That polycap right there can cause the HOT to short if it's faulty. So we'll go ahead and check it and make sure that it's not shorted or open. And I'm gonna have to pull, I gotta pull this board off anyway to cap it, so we gotta pull this board off to be able to change this HOT out. And we'll just disconnect that. This runs around here. Yeah, we don't need to disconnect that one. It's missing a screw, so someone's had it off in the past. And they got the wires. They had it off to change this HOT. That's what they did. So we got black, red, blue, and there it is. Can I disconnect this completely? Yeah. Yeah, see, here's our DPC digital pin cushion and H size that come from our remote board. And I'll bet you we don't have to desolder those if we cut some of these zip ties. Ta-da! Look at that. All right. Okay. And I'm pretty sure this doesn't even need a thermal pad. Nope, it doesn't. Someone loaded up on this thermal paste that didn't even need to be on here. So yeah, there's no, see how this one has a metal backing and this one just has a plastic one. This is the package that doesn't require, it's all black under here. See? So I'm going to take this and right in the garbage it goes. Now this one does need the thermal, or the insulator. That's the word I'm looking for. So we'll get that through there first, and got it. Okay. Need to move this a little. That should be good. Alright, so that puppy's in there. We are insulated, I should say. Alright. Okie dokie. So now with that replaced, I'll show you what a HOT that works should read. And again, diode mode, negative lead middle, H outer pin should be about 0.7. I'm sorry, 0.47, but this is still warm. 0.406. 0.407, there you go. So about 0.45-ish, you know, anywhere between 0.43 or 0.432 to 0.47, somewhere anywhere in that range. What's it at now? See, 0.408. So it'll get to 0.43-ish by itself. But okay, so now let's make sure that that cap is not bad. C415. We're going to go to continuity mode. Uh-oh. Well, is there? I think there's a resistor in parallel with that. R427 is down in there. Does that read straight up 0 ohms? Or is that going across the... I don't know if that's right. That's why you check things, boys and girls. 427. 0.2 ohms. Is that let's look at this resistor. This resistor is brown, black, black, gold. That cap is in parallel with that resistor. So if that resistor is supposed to be 0 ohms, then that's what it's supposed to be. Okay. Resistor calculator, I got that saved here. Let's go to, what did I say? Brown, black, black, gold. Brown, black, black, gold. 10 ohms. And we're reading 0.2. Well, look at that. I mentioned that cap can cause HOT to short, and sure enough, we have 0.2 ohms on there when it's supposed to be 10. So again, remove the component from the circuit and test again. So we will simply take the cap out as opposed to the resistor. Okay. Let's see. Let's see what you read out of circuit here, buddy. Well, if I could. Oh, well, you gotta desolder the right leg of the component. I had desoldered the resistor. There we go. Okay, capacitor's out. Just out of curiosity, we'll test it here on the bench. Then we'll put it in the component tester, see what it reads. But on the bench we get, okay, it's definitely not the capacitor that is reading the 0. Where's our component tester here? Okay, let's put this in 1 and 2, and let's turn it on here. We get capacitor, 1000 picofarads. So that cap is not our problem. Let's remove that resistor. I think I have another one of these that I can grab and take some comparative readings on, because I might be barking up the wrong tree here. There could be something else on the circuit that is shorted, that is supposed to be shorted, but we're not going across an inductor, L401, and it's not going across the output of the coil. Oh, wait a minute. Wait a minute. Wait a minute. So this leg of our horizontal drive transformer, this T401, this is our horizontal drive transformer. You'll see that these two legs read 0 ohms. Now we follow across this inductor, which is, well, 1 ohm. It goes across this inductor over to here, across this resistor. No, that's, yeah, I don't know. Yeah, this, so basically by going across here, now we still should read 10 ohms across here, because that resistor is supposed to be 10 ohms. But it always takes the path of least resistance. So if there's something else bridging that, like through that transformer or something, that could be the answer to this. And I'm probably barking up the wrong tree here. Okay, this resistor is now out. And does it read 10 ohms out of circuit? Yes. So yeah, I'm barking up the wrong tree. Those leads are obviously going through some other component, likely that transformer, but I'm going to grab another. I got another one of these downstairs in that monitor room. I wanted to grab one and just see what we read across this resistor in circuit along with that capacitor. Oh, come on. You can't even see what I'm doing, sorry. Okay. I'm trying to get this little bugger back in here. I knew I shouldn't have taken it out. It's never a component that's easily accessible. It's always one you can't freaking get to. Okay. Let's straighten you out. There we go. All right. Try again here. No. Well, let me get this back together and I'll come right back. Alright, so I got R427 and C415 back in, and I've desoldered one leg of that transformer. If we go across R427 now, we get 9.7 ohms. So, yes, I was correct. It's reading, these 2 points are reading across this winding of the horizontal drive transformer. So, yeah, see, there's 9.8. And I just soldered it back in so it's still warm, but there's our 10 ohms, and it's definitely, see now if I re-solder that leg of our drive transformer, now it's back to 0. So, okay, yeah, I was barking up the wrong tree there. So, alright, that's all good. So I think now there's really not much else to go over without powering it up to see what it does. So I'm going to do a full cap kit, a full reflow, including all this stuff here on the pincushion board. Then when I come back, we'll try and figure out what to do about this. I can probably, maybe, possibly, come up with something. I'm pretty sure I'm not going to have a connector. I'll have to come up with something for this, but in the meantime, I'll do the cap kit, the reflow, and if there's anything worth noting, I will kind of cut in and note it, and or save it and talk about it after we do the rework. Yeah, they got, see these caps here? How they're sitting them way up off the board is because this is your thermistor for your degauss circuit, and it gets very hot. So to prevent it from taking this cap out, they take it up off the board and keep it away from it. And they glue these 2 caps to the side of the isolation transformer here. But over time, the glue has loosened, so probably have to figure out something with that, but that's later on down the road. So yeah, I'll get all that work done. And yeah, for those of you who might be new to the channel, I have a particular method when I do these cap kits. Instead of using the desoldering gun or desoldering braid or anything like that to remove the cap, all I do is I don't add, there's no need to add fresh solder. All you do is heat up one leg, heat up the other, and the cap should fall right out. So if we do this here, let's go 1, 2, 3, 4 seconds, cap's out. I mean, it probably would be just as fast with a desoldering gun, but you don't need one. Because that works just fine. Then we can just use the braid here to doop, doop. There you go, holes open. You know, in roughly 5 seconds, if I hadn't have been narrating, we could have had this cap out, and it's ready for a new one immediately. So that's what I do for all these caps. So I'm going to go through and do the cap kit, the reflow. Anything worth mentioning, I will cut back in and mention it, and or mention it after I come back. And then this will be done. So I guess ready for testing technically, including all of this, and then we'll figure out what to do about this and see if we can get it working. Okay, all done. full cap kit, full reflow. I didn't do the filter cap because it's working, so I tend to only change that out if there's a problem with it. So all the neckboard rework's been done. I didn't find any issues of note, no caps that were bad or leaking, no damage anywhere, no lifted traces, no really anything worth reporting. So yeah, everything's done. And I also kind of off camera, I got all this put back together and on the side here. So I did not have a proper cap kit for this particular model. I used a 2515C cap kit, which doesn't include any of the caps for the, well, it does include, it includes some, but not a majority of the caps. It does not include this 5.6 microfarad bipolar cap. So I used two 4.7s. I used a 4.7 on the front, and then I put another one here in parallel with it on the back to get about 9. So it's higher than 5.6, but it's not going to hurt anything by having 9 in there versus 5.6. That's the only solution I have on hand, but that'll be fine. Ideally, you'd want to use the original 5.6 rating, but putting the 9 or so microfarad in there, it's fine. I've done it before twice, and it's fine. So that's the only real anomaly. So those are in there like that. You can see that one there and the one behind there in parallel behind it on the board. And this is all back together and everything is ready to go. Now the last thing here, I mentioned off camera, I got this back together, but I also went downstairs to another one of these that I have that I showed, not really up close, but I had 2 or 3 of these on hand sitting on the shelf. And this is the remote board for what should be on here. So if we look at this one is what, this one has the connector there. It has the digital pincushion pot and the horizontal size pot, but it's missing the standard pincushion. So it turns out that you can just move, oh, it's the same rating. It's the same rating for R322, R322, both of these. So I just took the pincushion pot that was in this spot and moved it to this spot. So all I had to do was find an appropriate horizontal size pot. Now this is a 50K ohm pot. So I found a 50K ohm pot and put that on there. So I moved the pincushion pot to the digital pincushion pot position and installed a 50K ohm pot in this position, and it's actually identical. The boards are identical. The traces, the layout, they're both the 94VO, things like that. So they're both identical boards. All I have to do now is see if I can find a connector or put some header pins there or something. But I wanted to show that this is actually the same board. All you do is move that pot over and then install this one, and that'll work. So I need to put this back downstairs, but I also need to set this aside. So we're going to hook this up and power it up, and assuming that it works, you know, I think what happened was, I think this was probably working and somebody plugged in the wrong remote board or something like that, and having no horizontal size pot in the circuit took out the HOT, and then they put a new one in, and again, same thing. So I'm fairly confident, you know, hopefully, that all this needed would be capped, reflowed, a new HOT, and then the proper configured remote board. And, you know, fingers crossed it'll fire up and work. So I need to see about, is there, let's see here, is that's 3 wires. I need one that's 4. I got a little overzealous in bringing the camera back on because I had planned on doing this off camera too when I did this, and I I got distracted, started doing the caps and everything in the reflow, and I forgot to find a connector. So let me find a connector that'll work for this, and I'll be right back. Okay, so mission accomplished. I was able to locate over here in the parts closet a Neotec that had the exact connector that I needed, and here it is. So I'm going to clean this up real quick. Get some of the solder off of these legs so it goes in the board a little easier. Straighten them all flat, and I think that should work. So let's clear these holes out. And let's make sure that it plugs in the right way. So we'll connect this to here. Yep. And let's gonna go in this way. Nope. That one's just getting pushed out. So what we need to do is bend that over, push it down. There we go. Gonna have to do a little better job of cleaning this off here. Let's see if that works. So I'm guessing, all right, so this has to go this way. Perfect. Nice, okay. We'll solder that in. Got it. All right, and with that, we can plug this connector in, like so, and we are ready for testing. So let me get this on the tube and we'll see what happens. Okay, we are ready to go, and like I say, we're using a 25-inch K7500, and again, ideally you really wouldn't want to do this long term, but for some quick testing just to see if it powers up, works, and everything is adjustable, and we have a good image and all that, it's fine. So TPG, I forgot to put it on medium res. Okay, we'll turn that on, and we have our meter set up to read volts DC, grounds on the frame, positive is on the leg of R117. So we have our anode, neck, yoke, ground, power, the video, and the remote board is connected. Let's make sure it's not causing a problem, or we can have it readily available to adjust. There we go. Okay, what's going to happen? 1, 2, 3. It works. At least it comes on. And we're at 109, and we need to adjust some sync. H hold here will adjust. Nope. I'm going to adjust my B plus to 113.5 on the pot here. Close enough, 113.3. Call that fine. Yeah, if we change this to something is screwy there, let's adjust our H freak pot here. There we go. All right, so we have a sync not hooked up properly. Oh, got it. Just a loose connection here on the CGA. It's working. It looks like absolute garbage, but it is working. Do we have H size? Yes. And you can see how the pin cushion's being adjusted there. So we'll adjust, let's do, let's brightness. Ah, nice contrast. Let me get the camera on the tripod here and we'll try and do some adjustments fiddling around here. 113.6, B plus is perfect. We'll get the camera on the tripod, do some fiddling and adjustments, and see what we can do with this. Alright, so let's get this screen here. It looks like complete ass. Let's adjust our focus here. Someone was probably playing around with the pots trying to fix this. Oh, crystal clear. Outstanding. Alright, so H position. We'll go there. Let's adjust our digital pincushion pot. Okay, so that doesn't help much. So we need to adjust the one on the sideboard here. Nope. This could be attributed to the fact that we have the wrong yoke on here, so I'm not going to get too worried about the pincushion stuff. Because without testing this on an actual dedicated yoke for this, it's hard to say. Like I say, this is just going to be used for testing. And ultimately, we're just going to make sure that it works. So if we do H position there, I want to adjust our secondary H position. There we go. Right about there is good. Vertical size. Yeah, let's adjust our linearity pot because that is not good. Where's my linearity pot? Oh, it's right there. Yeah, roughly. I mean, that's the issue I have. This is definitely a TPG problem up here, but I think that's fine. Vertical size works. Obviously, vertical hold works. Vertical position also works. Yeah, the digital pincushion, I do get some movement a little bit with the pincushion pot, but yeah, the other one here on the sideboard does this kind of thing for the phase. So roughly there's the phase. I mean, I'm not going to worry too much about this pincushion problem because, like I say, this is not the right yoke. But for testing, we can use it. I've only said that 10 times now. But let's turn this off and back on. Yeah, this is a TPG issue. Let me get an actual... Oh... Haven't done medium res in so long. I'm going to hook up a Cruisin' USA board here. We'll swap over the video input here. There we go. Now we can adjust our colors and stuff like that. Brightness is all the way up, contrast. So yeah, someone was messing around with these pots on the flyback. And that looks good. Wow. Other than the pincushion problem, but this is, like I say, this is meant for a 27-inch, which is partly why we have the pincushion problem, but that looks really good. Vertical position. Yeah, see, there's no... That problem up on the top of the screen is a TPG. The battery's getting low, but if we adjust our H size, we absolutely have H size, and turning the H size down gets rid of the pincushion problem, and yeah, not bad. Yep. I will say it is absolutely repaired. Further testing needs to be done on an actual true 27-inch tube and yoke, but evidence right here. You can use the Neotec on the 7500 for quick testing, which, as I've said before now, but proof positive. Turn the contrast down slightly. Yeah, turn our H size back down. Yeah. So, yep, I'm absolutely confident that if we got this on the true 27-inch yoke and tube with the right yoke, this will be perfect. So I can test that in the future, but for now we're going to call this repaired. Man, it looks good. So, yeah, sorry about this camera's too cheap for me to lock the refresh rate. You know, so I apologize about having to watch it like that. If we back up a bit, maybe it's not as bad, but anyway. So there we go. So I don't know, and B plus, by the way, is a solid 113.4. So, well, now it's 0.67. Depends on what's on the screen, but B plus is perfect. So I'm confident that what happened here was someone probably hooked up the wrong remote board, and not having a horizontal size pot in the circuit took out the HOT, and then they put a new one in, and of course, same problem. So yeah, I can't run this long enough to verify if the flyback has focus drift or brightness drift. I need to hook it up to an actual dedicated yoke and 27-inch tube and whatnot. I'm tempted to go down and get the 27-inch 7500 and see if it's better on that one, but maybe in the future or later I'll do that off camera. It's not a big deal. But for the purposes of this video, this is repaired. So again, as I say always, hopefully you learned something. Make sure you like, share, and subscribe. I appreciate you watching. And as you know from the beginning of the video, there's lots more on the way, so stay tuned for that. And thank you, and we'll see you then.